Roger Liu here, and welcome to the 6th installment of the Virtual Cities Unity tutorials. In this video, we'll be building a time controller object that will allow us to represent simulation time and control the speed of the simulation rate, or the time scale of the simulated time. Oh, I also wanted to mention that you might want to disable your main camera. You can do that over here in the inspector. We're not actually using the camera, and so your computer's just using power to render the scene, but we're just basically using the editor, so we can just look in here and we should be fine. So what I want to do is just organize this a little bit by closing things, and then I'm going to create an empty game object named Time Controller. And then I'm going to move this up to the top because I just think it makes more sense up top. And then inside of my scripts folder, I'm going to create a C# script named Time Controller. I bet you didn't see that coming. Then I'll wait an arbitrary amount of time and attempt to add it to... Oh, actually maybe that box up there tells me when it's ready. And I'll add it to my game object and open up. Alright, so we want our simulation to run much faster than real time. We also want to be able to know the day, the day of the week, months, parameters that are related to Gregorian time, because a lot of the data that we'll find will be expressed in those units, and a lot of the parameters that we're defining, or the attributes that we're defining on our game objects, are also in those units. So if we can think in familiar units like monthly rent or annual rates, stuff like that, then it just makes it easier to go back and forth. So we'll get started by creating a public. I can type public int year. Actually, I want these to go fastest to slowest. I'm not going to worry about seconds, so I'll do minute. Public int hour. Public int day. Public int month. And public int year. And then we'll also want public int day of the week. And we're not actually going to bother to try to align it to the actual calendar or an actual year. It's just going to start at 0 year, if that makes sense. And then we'll kind of go from there. So what we want to do is update these in our update function, and update runs every single frame. And that way other scripts can reference the time controller to figure out the simulation time. And what we want to do is assume that 1 second of wall time, at least for now we'll assume that 1 second of wall time equals 1 hour of simulation time. We can get the time since the beginning of the game by using Time.time, and this returns the time in seconds since the start of the game. And I'm going to set this to a variable t, and that'll just make it easier to deal with, because we're going to reference it over and over again. Then we can calculate the day as t divided by 24, right? So if every hour is a second, then after we've reached 24 seconds, then 24 divided by 24 is 1. So assuming we start on day 0, that makes sense. And then this is red because it's telling me it's not an integer. And the next thing we want to do is calculate the day of the week. Oh, I did a lowercase t. That's the problem. Go ahead and rename that real fast. So then this would be day divided by 7, assuming there's 7 days in a week. Or actually, this needs to be day modulo 7, because day of the week repeats. And again, modulo returns the remainder. So when day is 0, 0 modulo 7 will be 0, and then it'll count up 1, 2, 3, 4, 5, 6, and then it'll go back to 0. And then we can calculate hour as t modulo 24, because that'll repeat over and over again, kind of like day of the week. We can calculate year as day divided by 365. Our day will actually keep counting up past 365 the way it's implemented. We could have a day of the year variable. And then we would calculate that as day of the year equals day modulo 365. I guess we're ignoring leap years by doing it this way. We need a minute equals int, and then for this we can look at the decimal part of t. So we want to do t, and then we want to just get the decimal part. So we can do mathf.floor t, and there's 60 minutes in a hour, so then we would want to do times 60f, and actually this whole thing needs to be like that so we get the order of operations correct. So it'll do t minus floor of t, and then it'll times that times 60, and then it'll do the int conversion. Alright, the months are a little bit trickier because not every single month has the same number of dates. Let's just kind of partition this problem by creating a method for it to call. So we'll say find month. Alright, and then this obviously needs to return an integer because we declared month as an integer. So we'll say int find month. By creating an array, this is something that you haven't seen before. Again, an array is a little bit like a list. They're a little bit more efficient. And actually we can keep this in our class namespace, and that way we're not redeclaring it over and over and over again. And we want this array to define how many days are in each month. So we can say int, and then there's 12 months, so we'll say 12. Actually, sorry, we'll do int, and that just says like it's an int. So up here we can declare an int array that defines how many days are in each month, and so we'll call that days, or let's call that num days in months. So that. And then we'll initialize that by saying new int. And then we can define this number of days in each month. So January has 31.
February has 28. March has 31. April has 30. May has 31. June has 30. 31. August has 31. September has 30. October has 31. November has 30. And December has 31.
Alright, so let's do a quick check here. Oh. Okay, so that looks good. Okay, so then down here, and basically what we can do is have a for loop. So we'll say for int I equals 0, I less than num days in month dot count, or length. So that is one difference between an array and a list. So an array, when you have arrays, you have to do dot length, and then when you have lists, you have to do dot count. And then we'll do I++. And then we'll also need a variable, an int, that we'll call c. And we'll see how this works in a sec. So then we'll do c plus equals num days in month at I. So the first time through the loop, I equals 0, and so num days in month is 31. We initialize c to 0, so now c is 31. So our days start at 0, our day count. So then we know that if day of year is less than c, that we're in the I month. Does that make sense? So then we can return I, and that would actually break us out of the loop. And then this is still complaining because say we get to the end and we didn't return. So, you know, say day of the year was 375, like we have a bug somewhere else. Then when we got to here, we wouldn't actually be returning an integer. So I'm going to return -1. Okay, so let's test this out and see if it behaves like we're expecting. So our minutes are counting up. Our hours are counting up. And our day counted over. See if this pauses when we pause the editor. Okay, so that pauses. Okay, so you could imagine you might want some more fine-tuned control over this. Alright, so let's go ahead and create a public value named time scalar. And we want this public so we can manipulate it from the inspector. So let's go ahead and set it to 1. And this will be in units of hours per second. So if we wanted it to run 3 times faster, we could change this to 3. That's the end goal here. So we could do var t equals time.time times time scalar, but that might not actually be the best way to do this. And the reason is it'll work great if you set time scalar and don't change it, but you won't be able to dynamically change the time scale. So what we can do is make t a attribute of the class. So right now it only exists in the update loop and then it gets forgotten. But if we declare it up here, it will be remembered. This one doesn't need to be public. So we can do float t equals 0. It's 0 by default, but makes it slightly more explicit. And then in here we can do t plus equals time.deltatime. And this gives us the time in seconds it took to complete the last frame. And then we can multiply that times our time scalar. Alright, so I fired up Unity and I'm kind of testing this out, and it looks like it's behaving like we would expect. So right now it's running at 4 hours per second. I can change this to 8. The day or the month should swap over once it reaches 31. Swapped over. "24" would be 1 day per second. So before we wrap this up, there's one other kind of annoyance I want to take care of. So right now these are kind of showing as fields that are editable by the user, and I want to make it so it's clear which fields are there to show you a value and which fields are actually manipulatable from the inspector. So to do that, there's a little trick. Alright, so we can incorporate this little trick by lev. Basically what we want to do is create a show only attribute script. I'm actually going to go to my assets folder and then create a scripts folder in here. And then I'm going to create another file named show only drawer. And a drawer is kind of what they call, well, people will refer to these as slots. I guess the official term is drawer. And this will need to be in an editor folder. And then to use this, basically we just need to use this show only decorator before we declare the variable. So that implies in here. And then we can switch back to Unity. Alright, so yeah, that looks like it's working, and that definitely reduces some confusion. Probably would be good to apply that to some of our other scripts as well. So with that, let's go ahead and wrap up this tutorial, and I'll catch you next time.